Okay, I'm going to go over this start-stop buttons with a motor starter for a three-phase setup. Now, I did get some help from some guys at the Practical Machinist Forum about wiring to confirm. This is kind of an older contactor. It's from Italy, and it's called Gisalba, Gisalba. And basically it has a contactor, has the heaters involved with it, which are adjustable via a slider. There's a reset for this thermal overload, and there's auxiliary contacts. So there's a set of main contactors that your three-phase wire comes in and goes out to the motor and it's protected thermally. But there's also a set of auxiliary contacts, a set of normally closed and a set of normally open contactors that run in conjunction with this coil. Basically, it's an electromagnet that slams shut and lets power pass through this giant relay. And then down here, there's another set of relays. And if you look at it, there's a schematic on the side, and it shows you which one's normally closed and which one's normally open. Basically, that's what a relay is. It's a set of stuff that's normally open or normally closed, just like a light switch or a momentary switch where you push it and let go. Now, the benefit of these, say for example, if we just wired this up when we push the start button, as long as you held it, it would run. But with this auxiliary contactors being normally open or normally closed, when this is energized, it's going to hold the electricity for you. Okay, so that you don't have to hold the start button. But most importantly is if you lose power, it's going to shut the system down until you come back and push start again. Can you imagine a table saw with the blade spinning? You lost power. You're looking around the shop, you got a board in your hand, and all of a sudden, boom, it comes back on and kicks that board through your teeth. And that wouldn't be fun. So this is the benefit of the start-stop system here. So basically, the switches have contacts or leads on each side, okay? And the way the stop switch is the stop switch is normally closed. If you took a continuity meter and measured through it, you'd get continuity through there. It would go beep, and when you push the button, it would open up. And the start is the exact opposite. It's normally open. What you have to do is you're going to have to set these switches up into a series circuit, meaning that you're going to attach the start and stop switch. Instead of two separate circuits, it's going to be one circuit like a horseshoe. Okay, all the contacts are in series. Now I'll start looking at some of these wiring. Let me go over this real quick too. There's a coil down here. It's a 220 volt coil, and it's designated 90 and 99. 90 would be A1 and 99 would be A2. That's the electromagnet. When you get voltage to it, 220 volts in this case, it's going to close the contactor, and when it goes away, it's going to open up. Okay, and then there's set down here is another relays for the thermal overload. Again, we have our auxiliary contactor. It basically runs in parallel to the main contactor. That, you know, when it's, you have a set that's normally open and a set that's normally closed. And in this case, this top two are normally closed. If you stick a continuity meter through there, you'd find out that those are closed all the time. And then these are normally open. So let's identify where the wiring is on this. On the stop switch, not on the bridge side, but on the opposite side of that stop switch, it's going to run up and it's going to go to L3. Now L1, L2, L3 stands for line 1, line 2, line 3. That's your main power coming in from your breaker panel or your disconnect. Okay, so basically you're going to get 120, in this case it's 223 phase. Each leg has 120 volts, but when you measure it phase to phase, you get your 220. So L3 goes to this side of the stop switch. On the start switch, it's going to run and jump into the coil. So basically, we have some normally open auxiliary contacts, and on the top side of those contacts, we're going to come out of the start switch, and we're going to run up to the normally open, and we're going to connect it there, and then we're going to jump out of that, and we're going to go to the 99 or A2 side of our coil, and that's going to supply our 220 volt when we push the button. On the other side of that start switch where your jumper is, you're going to run up and go to the opposite side of that normally open auxiliary contact. Now down here on our thermal overload with the trip right there, you're going to find that there's a leg that feeds both circuits. You see this Y here? You're looking for the normally closed side, so I grabbed a meter and I put continuity check through those two and found that these two lines are the normally closed. Alright, so of those, on the normally closed side, the feed leg of it, it's going to go over here to the coil, L1, okay? And then on the opposite side, the normally closed, it's going to run over and give us the other connection to the coil on A1. So that's it. That's the whole circuit. We're going to bring in our 3-phase here. We're going to hook our motor up here, here, and here. And when we push our start button, it's going to start the motor. And when we push the stop button, it's going to stop the motor. That's it, guys. Thanks for watching.